Hey, what's up everyone? Today we're going to be talking about equations of lines and planes. Let's get started. Let's say we have a line and we want to find the equation that describes it. To do this, we need two puzzle pieces, a point and a parallel vector. Once we find these pieces, we can plug them into this equation. R of t equals x naught y naught z naught plus t a b c, where the point goes where the x, y, z is at, and the vector goes at the ABC. Let's do an example. Let's find the equation of the line that passes through A, 1, negative 1, 0, and B, 1, 2, 3. We need to find the equation of a line, so we need two things, a point and a parallel vector. Lucky for us, we already have a point. Let's pick this point A to use. Now, there are no vectors that are immediately given to us, but no worry, we can make a vector. Know that we can construct a vector starting at point A and ending at point B by finding the distances between the x, y, and z coordinates. After doing some subtraction, we get 0, 3, 3. Now that we have our two puzzle pieces, we can make our equation, and we end up getting r of t equals 1, negative 1 plus 3t, and 3t. And with this, we are done. Now, let's shift our focus on planes. Say that we have a plane and we want to find the equation that represents it. To do this, we need two puzzle pieces, a point and a perpendicular vector. Once we have these two puzzle pieces, we can put them into this equation. A times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. The x naught, y naught, z naught is the point, and the ABC is the perpendicular vector. Note that we can also rewrite this equation as ax plus by plus cz equals d, where d equals a times x naught plus b y naught plus c z naught. Let's do another example. Write an equation for the plane that contains the points a, 1, negative 1, 0, b, 1, 2, 3, and now c, 2, 1, 1. Since we're finding the equation of the plane, we need a point and a perpendicular vector. Well, we got 3 points to choose from, so let's pick A. So we have 1, negative 1, 0. Now, to find the perpendicular vector, we need to do something a little bit more creative. We know that crossing two vectors gives us a vector that is perpendicular to the crossed vectors. We already have AB, so we need to find another vector that is also on the plane, cross them, and we'll get our perpendicular vector. Let's do BC. Using the same strategy from before, we use subtraction and get 1, negative 1, negative 2. Now we have AB and BC, let's use the cross product. We use our previous knowledge to find the determinant, and the cross product yields negative 3, 3, negative 3. This is our perpendicular vector. Now that we have our two puzzle pieces, let's plug them into the equation. We ultimately get negative 3 times x minus 1 plus 3y plus 1 minus 3z minus 0, all equaling 0. And with this, we're done. Now for a review. To find the equation of a line, we need a point and a parallel vector. We use our two puzzle pieces to plug them into this equation. And to find the equation of a plane, we need a point and a perpendicular vector. And with these two pieces, we will plug them into this equation. Here is an example that you can do on your own. For the answer, click here. And remember everyone, understanding the concepts is only half the battle. Make sure you do plenty of practice to really hone these skills and master the material. Thanks for watching.